Alright, so hyperbolas we didn't get to talk about last year, but hyperbolas are this idea that we have a set of points whose distances from two fixed points, again called foci, have a constant difference. So the equation for hyperbola is similar to an ellipse, except we're going to be subtracting instead of adding. So since the order in which we subtract matters, the hyperbola opens in the direction of whichever axis comes first. So if our x comes first with the a, then it is going to open left and right. If our y comes first with the a, it's going to open up and down, like your y-axis goes up and down. So, to graph a hyperbola, we're first going to have to find that center, and we're going to have to create a rectangular box. No, your center is not always on your origin. Kind of like circles, we can move those around. It's going to change, that x minus 4 quantity squared is going to come up in these as well. Similarly, just like before, we're going to have to take the square root of the denominator to see how far left and right we go and how far up and down we go, just like we did on ellipses. Hyperbola has something that we talked about a little bit last year called slanted asymptotes, and those are going to go through the corners of our rectangular box that we're going to create from A and B. And if x comes first, meaning we're subtracting our y's, our hyperbola is going to open left and right, but if our y comes first, then the hyperbola is going to open up down. I think I just said that, but just in case I didn't. The only points that we need to show will be called vertices, which will actually be on the rectangular box. They shouldn't be anywhere away from it. So our foci this time, instead of being in the center of our shape, well, this time our foci are going to lie inside of our parabolas. Something like that. And I say parabolas just because we're a little bit more familiar with parabolas, but they're not actually parabolas, they're actually hyperbolas. Alright, so let's get this party started, shall we? X squared over 9 minus y squared over 25 is equal to 1. I see that it's a hyperbola. The main giveaway is that I've got x's and y's both squared, and I've got a subtraction symbol. And the nice thing is it's set up pretty nicely because it's equal to 1 already for us, so we don't have to do any work. Yes, sometimes it won't equal 1, but I'm not going to give you guys those too much. So now we just need to get started. So underneath my x squared, I've got a 9, so that tells me that in that x direction, which should be going right and left, I'm going to be going 3 from my particular center. And underneath the y, I've got a 25, which tells me that I'm going to be going up and down 5 from my center. So just like with the ellipses, I can find my center pretty easily. It should be up top in those parentheses most time, but this time I don't have parentheses, so my center should be at 0, 0. So from here, all I got to do is graph. Alright. So center 0, 0, go right 3, 1, 2, 3, bada bing. Go left 1, 2, 3, go up 5, 3, 4, 5, down 5, 1, 2, 3, 4, 5. But this time, instead of connecting them all and making an ellipse again, I can't do that. So I've got to go, and instead I'm going to make that little box that we talked about, that rectangular box. And it's not going to be a permanent thing, so I'm just going to represent it with a dashed line. And so why do I draw this rectangular box? Well, instead of having to do this lovely equation to try to find some slant asymptotes, which are a complete pain in the butt, what I'm going to do is I'm just going to draw my slant asymptotes through the corner of this rectangular box. So let me try to get a different color going on. And now I'm going to try to draw my slant asymptotes best I can. All the way through those corners. Alright, there's one of my asymptotes. Extend that back out. Cool, cool. There's my asymptotes. So now which way do I go? Well, I'm either going up and down this way, or I'm going side to side this way. So I look again. Hey, which one comes first? I see that my x comes first. I need to recall that, hey, if my x comes first, It's going to be opening right and left, just like my x-axis. It goes right and left. So I know that I'm going to take off from my center point because, well, that's the only point that actually touches that box. Other than that, I'm going to be going towards those slant asymptotes in both directions. Whee! Alright, towards my slant asymptotes. Doesn't have to be perfect. It's going to be a really wide one to start off. That's what it ends up looking like. Okay, then what do foci have to do with this? Well, in order to find my foci, I would actually have to take a squared plus b squared is equal to c squared in this particular case. A in this case is 9 plus 25 is equal to c squared. So c squared is equal to 34. All in all, c should be 5 point. So c should be 5.9, 5.8. Nope, yep, 5.8. So 1, 2, 3, 4, 5.8 should be close to 6, but it's not. 1, 2. Alright, so there's my focus. Focuses. Okay, there. Hopefully that stops popping up. But that's all it is. Ta-da!